Okay, so this is how you do the problem solving number one. Retention time or resident time, it's kind of the same thing, interchangeable terms, of lakes and reservoirs. So retention time is equal to the volume of the lake divided by its outflow. So outflow is a rate of water movement. You can rework this equation and solve it for volume, in which case you're multiplying both sides by outflow. So volume is equal to retention time or resident time times outflow. Or you could switch it and solve it for outflow if you divide both sides by resident time, and outflow is equal to volume divided by resident time. So the same equation, just kind of expressed in three different ways, solving for a different variable. Okay, so if I want to find out the retention time, how much time does it take the water to completely get replaced inside of a lake? That's what I'm solving for. If I want to find how much water is actually in a lake in a volume, like cubic miles or square cubic feet or cubic inches, something like that, I would then use this equation. And if I want to find out how fast the water is actually flowing out of the lake, I'm going to use this equation. Outflow is equal to volume divided by resident time. So if you look at our first one, Lake Smelsabad has a volume of 7,042 cubic miles of water and an outflow of 13.6 cubic miles per day. What's the resident time? So we are solving for resident time. So resident time is equal to, it's going to be our volume divided by our outflow. Our volume is 7,042 cubic miles. That's miles cubed. That's a volume. Miles is a straight distance. Square miles would be an area, and this is a volume, so it's cubic miles. And then the outflow is 13.6 cubic miles per day. Okay, and because miles cubed is in the top and the bottom of the equation, those will cancel each other out because you have per day in the bottom of the equation, and this is in a denominator. That will actually flip to the top, and my final unit is going to be in days. So my final answer is 517.79 days. Remember, we're going to round to two significant digits there. And what does that actually mean? Well, it means that it takes almost 518 days for all of the water in Lake Smelsabad to get completely replaced by new water. That's the resident time or the retention time of that lake. Okay, so if we look down at the second one says Lake Look Like Muck has an outflow of 18.81 billion gallons per day and a retention time of 362 days. So what's the volume now? We're using this part. We're solving for volume. So here we've set up the equation. Volume is equal to outflow times retention time. So 0.18 billion gallons per day times 362 days. Days is in the bottom of this equation. It's in the top here, so they're going to cancel out. And I'm going to end up with 65.16 billion gallons. I don't actually have to convert this to more of a whole number because I'm just going to end up with billion gallons anyway. All right. So this is telling you that this Lake Look Like Muck, has 65 billion gallons of water in it, 65.16. If you look at the next one, you're solving for outflow. Remember, outflow is volume divided by the retention time. Okay, V over RT. So 19.68 billion gallons of volume divided by retention time of 220 days. I'm going to end up with 0.08945 billion gallons per day. And if I convert that to a more usable number, if I just move the decimal place over three places, going from billions to millions, I've got 89.45 million gallons a day. Either one of those would be fine to work with as an answer. Okay, then we'll look at number 4. So with number 4, we're actually talking about the Green Lane Reservoir and the real life numbers that we have here. Okay, we know that it has an outflow of 72 million gallons per day. That's how much water is flowing over the dam. We also have a volume of 4.346 billion gallons of water. That's all the water that's in the reservoir itself. Okay, so I'm going to show you two different ways. First is using scientific notation, and then second without. Easiest way, I think, is use scientific notation. So here's your 4.346 billion gallons right here. Okay, and then here's your 72 million gallons per day, written out as whole numbers. Now, if you convert those to scientific notation, if your decimal point is right here, you're going 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, so it's 4.346 times 10 to the 9th gallons. Okay, your decimal point would move over 9 spaces, so that's why it's this number times 10 to the 9th. Okay, this one you'd move the decimal point over after the first whole number. That's 7 spaces, so 7.2 times 10 to the 7th gallons per day. So you divide these numbers, divide the whole numbers, and when you divide with scientific notation, you subtract the exponents. So you're going to end up with 0.6036 times 10 to the 2, right? 4.346 divided by 7.2 gives you this whole number. 10 to the 9th minus 7th, so 9 minus 7 is 2. That's how that works. And then to write it as a whole number, you would just move the decimal place over 2, and your final answer would be 60.36 days. This is going to be days because we're talking about resident time. So if it's a time, it's going to be days, something like that. Okay, now I'll quickly show you how to do this without actually using scientific notation. Okay, so the first thing you need to know is that 4.346 billion gallons is equal to 4,346 million gallons. So to go from billion gallons to million, you're just moving that decimal place over 3 spaces, and then you'd have millions of gallons. Okay, so here's our millions of gallons, and now we have our volume and our outflow both in the same unit in millions of gallons per day. So then we can just solve for that. So when we then divide it by 72 million gallons per day, our gallons will cancel out. Days pops up to the top because it's in the denominator in the bottom of the fraction, and our final unit is in days, 60.36. So you don't have to go through the scientific notation part of it if you know that 4.36 billion is equal to 4,346 million. Okay, so then we'll look at the last question real quick. I'll just run through the equation. So if you read through this prompt, you see this sentence here, how long will it take for Lansdowne to feel safe? They're asking you for a time. So you're trying to solve for resident time here. They gave you the volume, they gave you the outflow, and they're talking about how long is it until all that water gets replaced and they'll start to feel safe. So there you just take your volume of 213 cubic kilometers, divide it by your outflow of 78.5 cubic kilometers per year. Years will pop up to the top because kilometers cubed will cross each other out, and you're going to end up with 2.71 years is how long it will take. Now this other question here says, can you think of any reasons why at least a portion of the waste would remain for thousands of years? The biggest reason is that probably it would get stuck down in the mud in the benthic zone. Okay, and that's the reason why the benthic zone is most susceptible to pollution, because it's probably going to retain some of that pollution that normally would get washed out in completely water-soluble stuff. All right, so that's how you do those types of problems. All you need is to know how to solve for any of those 3 things and keep track of your units.